Welcome to GATE 2021 model courses on control systems. Today's our topic is signal flow graph. Let us see the question number 3. We have determined the transfer function C by R for the signal flow graph shown here, and these are the options given. Let us go to the solution. How to solve this question is, normally if you apply the Mazur's gain formula, since R is an input node having only outgoing branches, C is having only incoming branches, which is an output node. You can apply Mazur's gain formula, that is finding forward pass loops, 2 non-touching loops, 3 non-touching loops, and substituting, you can definitely get the answer. But that becomes more tedious for this problem. This problem you have to analyze in this manner separately. Separately, one part of SFG acting alone, you have to find the gain again using Mazur's gain formula. First, we'll find this part of SFG only your gain C by R, and next second part this one, third part this one. Individually finding one part of signal flow graph gains. When all are connected, then we can write the overall transfer function as sum of the individual gains. Actually, these concepts relates to the diagonal canonical form. Whenever we will take a question on the diagonal canonical form in state space model, again we'll be recalling this question. Okay, let us go to the solution now. See, individually one part will find the gain. What is the gain of this particular signal flow graph is? The mathematical formula will be P1 delta 1 plus P2 delta 2 by delta only, where P1, P2 are forward path gains, delta is the determinant of the graph, which is given in terms of 1 minus of sum of loop gains plus continuous. Now, how many forward path gains will have from R to C is only one forward path gain will be having, that is straight away we can reach in this manner. What is that gain is 1 into 1, which is 1 only. What is delta is 1 minus of sum of loop gains. How many loop gains we have in this SFG? This is one loop gain, which is minus 1. This is a second loop gain, which is also minus 1. This is again a self loop gain, which is plus 1. So totally 3 loop gains are there. One is minus 1, second one is also minus 1, third one is plus 1. Out of these 3 loop gains, how many 2 non-touching loops you can form it? 1 and 2 touched, 1 and 3 not touched, 2 and 3 again touched. For only one pair we have it, 1 and 3 loops are not touched. What is 2 non-touching loop gain is minus 1 into plus 1, which will be minus 1. What about delta 1? In forming this forward path gain, all the 3 loops are touched, hence delta 1 will be 1. Hence, your answer will be 1 by this 1 cancels. 1 plus 1 to 2 minus 1 is 1. There is nothing but 1 itself. Next, come to the second part. How many forward path gains we have from this input to output is only one forward path gain 1. And delta is 1 minus of loop gains, in which how many loop gains we have in this SFG also 3. One is this one, which is minus 1. Second loop gain is also minus 1. Third loop gain is also minus 1. So total we have 3 loops. All the 3 loop gains are minus 1, minus 1, minus 1. Any 2 non-touching loop gains you check. 1 and 2 loops are touched, 2 and 3 touched, 3 and 1 also touched. But there are no 2 non-touching loop gains, and delta 1 will be 1, since in forming this forward path gain, all the loop gains are touched. Hence, the second part of SFG gain is 1 by 4 or 0.25. What about this third one is, check it. C by R is equals to, how many forward path gains we have from R to C is only one forward path gain, that is nothing but 1. How many loop gains we have? It is 1 minus of, this is one loop gain, which is minus 1. Second loop gain is also minus 1, this one. Third loop gain is also minus 1. Fourth loop gain is plus 1. Totally 4 loop gains are there. 3 loop gains are minus 1, minus 1. Fourth loop gain is plus 1. Plus 2 non-touching loop gains. 1 and 2 touched. What about 1 and 3 not touched? For one pair is minus 1 into minus 1, which is plus 1. What about 1 and 4 also? First loop and fourth loop also not touched. That is minus 1 into plus 1 is minus 1. Next, what about 2 and 3 touched? 2 and 4 again not touched. That is minus 1 into plus 1 is minus 1. Next, What about 3 and 4? Again, touch. Therefore, there are no more 2 non-touching loop gains. Any 3 non-touching loop gains, also you can check it. There are no 3 non-touching loop gains. And informing this forward path gain, all loop gains are touched, hence delta 1 will be 1. Or if you simplify this one, what is the gain we'll be getting is 1 plus 2 minus 1. This will be 1 by 2 or 0.5. For now, what is the gain of the given signal flow graph is sum of your individual parts SFG gains only. The first part SFG gain is 1, second part gain is 0.25, third part gain is 0.5, hence you'll get the answer as 1.75. Hence your correct option is C. Thank you.